Good morning, everyone.
Good morning, Anup.
Morning. Uh, Welcome to the second round of our panel discussion series on advantage manufacturing. Many of you may have had access to our previous session. You might have participated. For those who missed it, we have a recording available on YouTube, and you can request through your chat box, and we will send you the link. The rules for today's panel discussion are as follows. We have an eminent panel of 6 speakers. Each speaker will be called one by one to take a particular topic, and the panelist will speak for 8 to 10 minutes. At the end, we are going to have a round of audience poll. Last time we did a few more polls, but this time, since we have reduced the overall duration of the webinar, we will take one poll at the end, and then we will keep the last 10-15 minutes available for question and answer session. So as and when the panelists do their talk and you have a question, you could flag it. Our team will select and shortlist, and we will take 5, 6, 7 questions depending on the time available at the end. Today's webinar will be wrapped up by 12:30. So it's a 1.5-hour session, and we hope to have more people join in the next few minutes. That's always been a trend. So as we wait for them to come, I will move to the next part of the introductions, which is really setting the context for this second round. Last time we spoke a lot about startup reboot. We will continue to talk about that, but we will also try and attempt to find our definition of a new normal. It's pretty clear that things are not going to remain the same. Disruption is going to prolong, and as a result of that prolonging of disruption, certain changes will occur in the business system, certain changes will occur in the deployment of technology, and certain changes will also occur in the kind of people available for manufacturing operation. Also, we are all aware that travel is going to be severely curtailed, international and domestic, and many nations are also going to try and reshore manufacturing operations. So net, what do we expect as a new normal? We'll try and get some ideas on that as well. Many of you might have noticed, and with a lot of alarm, that yesterday we had a major accident in Vizag, and it left 11 people dead. Now, if I could take the COVID analogy, 11 people dying means probably around 400 odd positive cases, the equivalent of that, and all happening in one day. So while we are worried about a major disease and protection from that, I think there are some indicators that the new normal is not going to be easy on us. Forget the changes. I think it's going to demand a lot of discipline and a lot of soul searching as to how and when we can restart. So given that backdrop, and given the fact that physical distancing, I'm deliberately using the word physical distancing and not social distancing, because I think socially we are all very well connected. Perhaps we are even better connected thanks to technology. But it's the physical distancing which is definitely going to be a new norm. What are the implications for big plants? What are the implications for smaller shop floors? And really, how can we go with a safe touch operation? So that's the kind of setting we have for today's webinar. I will now move you through the introductions to our panelists. Can we have the profiles of the panelists? Our first panelist is Mr. Dilip Sawhney. Mr. Sawhney has more than 27 years in industrial automation and in the healthcare technology industry. He's served many leading corporates, both in India and in America. He has been a member of the National Council of CII. Since 2008, he's served Rockwell Automation, and he's responsible for leading India's business in automation. Mr. Sawhney graduated with honors in electrical engineering from IIT Roorkee, and he has worked prior to Rockwell. He has worked with Larsen and Toubro, GE Fanuc, and here he is in front of us, going to lead today's discussion. Welcome, Mr. Sawhney.
Thank you so much, Anup.
Our next speaker is Mr. Sivaram. Mr. Sivaram graduated in electronics engineering from IIT Madras, and he has devoted his entire career in the field of industrial automation. Starting with BARC, where he worked in automation of power transmission and distribution communication. He has an overall very wide experience in DCS, SCADA, microcontroller applications. In 1996, he founded BNR Industrial Automation and was their managing director till 2017. Subsequently, he held the position of non-executive chairman, from where he recently retired in February this year. Currently, he is a mentor and an evangelist for digitalization and practices of Industry 4.0. So we hope to hear him speak about concepts very close to his heart, very much impacting not only the professionals, but also engineering students and faculty. Welcome, Mr. Sivaram.
Thank you, Anup. Happy to be here.
Yes, sir. Thank you. Our next speaker is Mr. Ravi Agarwal. Mr. Agarwal is currently the managing director for Pepperell and Fuchs Factory Automation and looking after their business in Middle East and in India. He's also our current president of the Automation Industry Association, and he also holds charge as director of the IIT Delhi AIA Foundation for Smart Manufacturing, which is located at the Haus Khas premises of IIT. Associated with the field of process and manufacturing automation for many years, Mr. Agarwal has earlier worked with the Industrial Design and Development Center at IIT Delhi, and he's also worked with the global major ABB. Mr. Agarwal, good to have you.
Thank you, Anup ji. Good morning to all.
Okay, now we move to our next speaker, Mr. Vijay Paranjape. Mr. Paranjape is a former director and a member managing board of Siemens Limited, from where he started his career way back in 1971 and retired in 2011. He was also the chairman of the board of Flender India Limited and the Siemens PLM business. He was president of Electronics Association 2008-2009, and thereafter he was the president of the Automation Industry Association 2010 to 2011. 2012 to 2016, Mr. Paranjape was an independent director on the board of Larsen and Toubro, or L&T Electrical and Automation Business Group. And currently he is an independent director with Jyoti CNC Automation and DOL Motors Private Limited. Always a pleasure to have you with our midst, Mr. Paranjape.
Thanks a lot, Anup, and well, I'm really happy to be contributor.
Thank you.
Our
next speaker is Professor Sunil Jha. Professor Sunil Jha did his PhD in manufacturing science from IIT Kanpur, and he has been engaged in teaching and research on manufacturing processes, computer-aided manufacturing, and industrial automation since the last 10 years. He has developed new unconventional super finishing processes and has filed 6 patents, and few of them have also been successfully commercialized. Before joining IIT Delhi, he has worked with Tata Motors Jamshedpur in the area of CAD/CAM and was engaged closely in digitalization of engine components and foundry tooling development. Currently in the capacity as Director, IIT Delhi AIA Foundation for Smart Manufacturing, Dr. Jha is closely supporting manufacturing industry in absorbing new technologies to make them ready for next industrial revolution. Today he is going to do just that. Welcome, Dr. Jha.
Yeah, good morning, sir. Thank you so much.
Our final speaker for today is Mr. Nandakumar. Mr. Nandakumar is the founder and managing director of the Chemtrolls Group. Started in 1975, Chemtrolls is now India's leading private solutions provider in the process analytics, flow and terminal automation, environment monitoring, process measurements, steam conditioning solutions, and utility management. Mr. Nandakumar himself is a chemical engineer with specialization in petroleum refining from Trichure, Kerala. He has worked with Cochin Refineries and FACT before embarking on his entrepreneurial venture. Mr. Nandakumar is a very respected and renowned figure in the field of chemical process engineering and process automation. I'm sure he is going to touch upon some larger aspects today, apart from technology, in terms of safety and environment. Welcome, Mr. Nandakumar, to today's session. Good to have you. Great. So we are now set up for the main discussion. Before I start, let's have a look at the audience. Okay, I think we have a fair number to begin with. So looking at the backdrop of today's context, one of the things clearly people are looking at, and it was even there in the first session, is remote monitoring. I'm going to request Mr. Dilip Sawhney to share with us what are the strategic choices in front of us, and with remote operation, is there a chance for safety to be compromised? Can we address and identify the weak spots, and also what is going to be the situation if decision makers are not actually present at site? Mr. Dilip Sawhney, your comments, please.
Sure. Well, thank you so much, Anup, and once again, a very good morning to everyone. Great to see a number of people from across the country, on the webinar today. Anup, I will address your question. I'm going to be using a couple of charts, so it'll be nice if you can, bring them up on the screen as I begin talking. So, as we had deliberated in our last session, technology and automation is going to have to play a front and central role in the way forward from here, right? And yes, you're absolutely right. Remote monitoring is a very, very important consideration, right? If I may, I would like to start from the context of a typical brownfield facility. Why brownfield? Because we are thinking of starting off what we have. Greenfield is something which we'll get to eventually as the life normalizes, right? So in a typical brownfield facility, the challenges that you would typically expect especially in the context of a cold startup, right? You're going to have limited workforce, and like you yourself said, physical distancing norms, and for the fact that also many of the migrant workers may have moved back, and these are people who had a lot of tribal knowledge, available on how certain operations needed to be carried out. You have lesser hands. B, you'll have those trained people no longer available on site, right? So essentially, you're looking at a set of challenges that include, and pay some attention to this graphic, which is there in front of you, typical facility. So there are considerations like safety, productivity, skill gaps, ensuring collaboration while people are remote and apart, right? Now, some of these challenges may certainly require some new investments, right? One of the examples could be if you did not have, a holistic safety strategy implemented. Anup, you alluded to the very sad news that came from Vizag yesterday, right? So safety is, front and central always, but never more so than what happened yesterday, which incidentally wasn't the only one. In the news, there have been other incidents from across the country too, right? But if you didn't have safety strategy implemented, then you have to consider one. Absolutely. So that could be new investment. But by and large, with some thoughtful planning and a good sound approach, you can surely transform your brownfield facility into one that is ready to meet the challenges of these times, right? And before I move on to answer your question, we must also recognize that this is not a temporary phase, right? You may restart and you may have to stop again because there might be a second wave or some such, right? So thoughtful planning and preparation has to go in terms of our go forward strategy. So that's one thing I wanted to just lay out. And if you can take me to the next chart, please. Right. So what I'm trying to say over here is not everything needs to be a fresh investment. And I'm taking the example of implementing alarms. Most of the plants, most of the facilities, factories, they already have the facility of alarms. But oftentimes what we've seen is that these are either overlooked or they're bypassed or simply not in use, right? Now, nothing can be worse than, you restarting and then running into an unplanned downtime, which could have been easily avoided if the alarms were not suppressed, right? So what I'll submit to you before I come to the topic of remote monitoring, what I'll submit to you all is back to the basics approach, leveraging the investments that you already have made, right? Because there's a whole lot that is already there in terms of the capability of the existing systems, right? Please pay attention to those capabilities, which sometimes in good, quote unquote, normal times used to get overlooked. They need not be overlooked now. They are going to be your, best friends, shall we put that way, right? As you go ahead and restart with severe constraints. So take me to the next page if you can, please. So as we transition, Anup, I'm going to now come to the point that you had asked me to talk about, right? Remote connectivity has become a very important consideration. There's no doubt about it. In our previous webinar, we discussed at length, about the role that technology in general has to play. And I think there was, by and large, very strong endorsement from the audience as well, right? When it comes to, accessing, your plant assets remotely, right? What's now becoming increasingly apparent is, the convergence between IT and OT, right? Which many facilities have already implemented. That's coming in particularly handy, right? So when you have this IT-OT convergence, you are able to access your OT assets. What are these assets? These are basically, devices, machines, equipments, and your plant-wide control systems like DCS and batch control, right? When more and more of these devices are out there, which you're accessing, you have to think of two things. One is, how do you establish access, right? Those things are now become, relatively easy to implement simply because there is prevalence of standard unmodified Ethernet across the factory floor, right? And that lends itself well to remote connectivity, right? But you also must bear in mind, and that's a point that you had asked about, Anup, right? You must also bear in mind with every new node that you're connecting, with every new asset that you connect, you're also creating a new access point, right? And unless and until you're putting close attention to to having good security norms. I'm talking about cybersecurity norms. You're going to be in for some root shocks. It could be your system getting compromised. At a minimum, it may give you a very degraded network performance. But in the extreme cases, it may have people that you really absolutely don't want to expose your manufacturing facility to gaining access to it. So that's something which you need to get some domain experts in this area involved with it, so that they can give you appropriate guidance on how to envisage the cybersecurity strategies. That is absolutely a must, and it should not be ignored. Right now, coming to when you have access that is established. Take me to the previous chart for a minute, please. Right, when you have access that has been established, what you are able to ensure with that is, there'll be a variety of user profiles or personas, people who need to access. You don't have to throw open your entire plant and your entire systems, available to people who are from within or outside of the organization, right? We discussed at length last time that remote collaboration is becoming exceedingly important, because you may have fewer people on site, but you need to support them from domain experts who may be remote, right? And sometimes these domain experts are external to the organization. With a well thought out strategy, you can actually give limited and very precise access to people who need to access a particular type of machines. And you can create appropriate subnets that allow them to access only that area of the plant or only that set of equipments, right? These things are practices that are being utilized by a lot of people across the country, right? So, if it is a well thought out strategy, you can sleep easy at night, because you know that your infrastructure is secure, performance will not be degraded, and access, when granted, will be just used for the purpose it is intended. That is the point I wanted to make. If you can move to the last chart, which is also my final one, right? I wanted to share with you this paradigm, right? And this is, call it an eventual vision. I'm calling it the connected worker, right? This concept is basically an extension of the industrial digital transformation that we talk about, right? It comes to the foreground in times like this. You'll have fewer and fewer domain experts who are going to be on site. So you'll eventually have remote operation centers that'll be, created, or pool of remote experts, who are physically dispersed, right? But they will need to be accessed sometimes in real time, right? Often in real time, right? By people who are on site. So the use of mobile and augmented reality technologies are already being used. This is no longer futuristic. This is happening right now. And if anyone is interested, I'll be happy to share, some use cases and also some success stories in this phase of lockdown, right? Where people right here in India have been able to use these technologies. I was on a call with a customer just this morning, and I was delighted to note some examples coming from their side, right? This is what needs to be borne in mind, though, is that, when you think of a digitally augmented, multi-skilled worker, why we say multi-skilled? Because there's a pool of domain experts who are enabling a worker who's in situ with the equipment, right? This is not a slam dunk technology implementation. It's not, right? In order to drive sustainable results, you need to do this in tandem, with people and processes. So people, processes, and technology are three legs of a stool, and you have to evolve them in tandem. If you don't, then the stool will not be stable, and your experience will not be a good one, right? So careful consideration has to be given to this change management. And I've quoted some things over here out of a study which was done by LNS, and they've laid out some recommendations which I'll let you read. So Anup, those were some comments from my side. Absolutely, remote technology is going to be a big enabler, but a lot of thought has to go in to make sure that we are not left with some unpleasant surprises. Anup?
Thanks, Dilip. And as I can see from this study recommendation, a lot of it talks about this structured, disciplined approach, culture, readiness, change management, analytics. So all this really is great technology. But when we are looking at remote connectivity, uh, there is a set of physical machinery out in the plant, and I'm going to request Mr. Shivram to take this dialogue forward from where Dilip has left us. We have to commence production in a safe manner, and the challenge will be to keep production going with reduced manpower. Now, we've heard about the concept of connected machines since a long time. Does connected machines address this need during the reboot and in the new normal situation? Mr. Shivram, what is your take on this?
Thank you, Anup. Good morning, everybody. And thank you all for being with us today morning in large numbers. Now this topic, coming straight to the topic, because time is the most premium quantity that is around for all of us, even in a lockdown. So let us get down to the brass tacks. Essentially, what are we talking about? Connected machines, connected people, remote working. All this means that we want to bring an element of smart into each one of our operations and our interactions. Now, when we come down to machines particularly, right, smart machines. Smart machines are an integral part of a smart factory. Now, what does smart mean, really speaking, at least in this context? In this context, it means to be articulate and to be aware. These are the two aspects on which we want to focus right now. An articulate machine can talk to other machines. It can talk to a service team. Which other machines? It talks to its neighbors. The neighboring machines are either upstream, downstream in the processing line, or across the aisle. That means it's another machine which is working in tandem with it, sharing the load. Who is the service team? Service team is a set of humans, maybe in the maintenance team, maybe in the repair team, but not apart from that, also the operator himself, and maybe the shop floor supervisor also. Now, how do they talk? There are two things. They can either reply to queries that we poll and they reply, or they can also autonomously call for attention. Reply to polling they can do and report their status minute by minute, second by second, and they can also report statistics of total production, quality data, etc. And autonomously call for attention with reporting of warnings or alarms. Right? And what is awareness now? The other aspect of it. Awareness is when the machine factors into its operations its information of its neighbors and the environment. That means that the production status of the neighboring machines and of the perhaps the line speed, etc. That is the environmental aspect of it. So, I mean, rather than going theoretically, you can see that the preceding seems to restrict everything to machines which are, let us say, intelligent. To be smart, you have to be intelligent, meaning you have to have an intelligent controller, which we generally call as a PLC. But that is not the entire thing. We will come to it, how to go beyond that. Now, the connection configurations. Now, there are many ways of connecting configurations. There are star and line and various things. But essentially, connection is either for a machine along the line, as we said, down the line, or a horizontal towards the machines working in tandem. Well, when they work in tandem and they can talk to each other, they can do a load balancing in a much better way. Similarly, connecting all machines to a shop-wide SCADA or a DCS system or a central supervisor is another connectivity. And connectivity of each machine by itself to a remote monitoring or a remote maintenance console is another way of connection. And fifth and finally, there is the connection to cloud for serving plant-wide functions such as data storage, analytics, MES, ERP, and so on. So there are connected machines can be viewed in any one of these various paradigms. Now, what are the benefits? Because why would you want to connect machines if there is actually what is the benefit out of it? The topic of connected machines, as Anup has so rightly pointed out, is nothing new. We have been talking about it since long. The benefits are also being publicized all along, and we will once again briefly look at those things. The point which I want to make is that the same benefits which were pointed out for regular times are equally applicable for abnormal times, such as this present crisis. If you want to look at improving operational performance, if you want to look at safety, if you want to look at emission standards, these were equally valid even in good times and also are valid in bad times, right? The connected factory over and above that had an inbuilt benefit available with it, which was the resilience of the production facility, that if adverse circumstances arise, how well it can cope with it, either through a means of a graceful degradation, that is reducing the performance without putting a shock on any one of the components, or to be able to bounce back, come back into full scale very quickly. One more aspect of this resilience today, which we learn to appreciate, is the ability to be able to scale the production level up and down smoothly as per short-term demand fluctuations. Because today the demand forecast is very difficult, and planning horizon can only be very short. So the connected machines will also offer you a benefit of being able to scale the production up and down. So the benefit statements of the connected machines, which as I said has been long touted and preached, let us say, if you can recollect, okay, reducing production bottlenecks during alarm situations, managing product queues, reassignment of target set points across the machines in case any one machine has a difficulty, balancing the load across the machines, benchmarking performance of similar machines to detect any anomalies that are coming up, and perhaps optimization of the raw material supply if you want to go in for a just-in-time kind of a procedure, supervisory control to tune production planning, which is what I meant by scaling. Over and above, also enable you remote monitoring and operation and connection to cloud systems. So this part of it fairly has been covered by my friend Dilip, so we don't go into that. Now, when we want to look at the startup phase, because that is what is coming to us in the front, hitting us immediately. See, during when you want to start up a machine which has been down since 40 days, yes, you want to do the setup and calibration once again. And during setup and calibration, normally there are many safety interlocks which are in a override status. Unfortunate but true. In such condition, how do you enhance the safety of the operation? You normally have a second person who will be double checking all the interlocks or all the operations so that safety is not completely violated. So if you cannot have so many people on the shop floor, you can use this remote connection through the connected machines to help in this circumstance. Similarly, if in a line you are commissioning one machine after another, and information from the previous machine to the downline machine can also help in providing higher safety during the not normal operative status of the machine. So these are some of the benefits which you can get over and above the benefits which have been always shown for connected machines. Now, as I indicated in the right in the beginning, there are degrees of automation. Different machines are automated to different extents. There are fully automated factories with all machines being having intelligent controllers. Even there, it is possible, and I've seen in many places, that these machines or these controllers are not connected, they are not talking to each other. They form islands. So this is the right point in time to be starting to embark on making it a connected factory. Yes, yet again I take a cue from my friend Dilip Sawhney, and he says it is never too late to start, and connecting the machines is not such a difficult task either. For those who do not have those automation, what I want to point out is that the controllers have been progressively more and more intelligent and lower in cost in accordance with the famous Moore's law, with the doubling of the capabilities every 2 years or something. There are also some factories which have only a few machines which are automated, or hardly any. They have only legacy machines. So how do we deal with that? Because it would be very cruel to say all these new ideas are denied to machine with no controllers, and we need to do it in a hurry. So I come up with a kind of a suggestion, a temporary solution, a jugaad solution, let us say, to add smart to a machine within a limited time. You could envisage a mobile trolley with a small diagnostic equipment. This trolley will have a micro PLC, let me say, with some connective terminal blocks for IOs, right? And a micro PLC which has a web server in it, right? You can connect the IOs of the machine to this terminal block on the trolley. The PLC can acquire it, and then using the web server, it can connect via internet to the remote laptop of a maintenance engineer who is working from home. Which means that you need to invest only on one trolley to service several machines on your shop floor, thereby considerably bringing down the cost aspect of it. Do take great care that you have to have a good cyber security in place in the form of a firewall, in the form of other authentications like passwords and biometric and so on and so forth. So that is a different topic, but no matter that you are collecting your PLC to your engineer, yet there is a possibility that you can invite unwanted guests into your shop floor. So do take care of cyber security. That is a thing which you cannot forego. I think this is a topic where I can go on for much longer, but I would say that I have to hand it over to the next person. So Anup, I will call it a close at this point and ask you to take over. Thank you, everybody.
Thank you, Mr. Shivram. So, we've spoken about remote connectivity as a technology piece. We've spoken about connected machines. And now let's move over to the other most important asset in a manufacturing operation, which is the materials. So taking back, control of the supply chain, which is inbound, outbound, and in plant, is going to be a very high consequence. I would now invite Mr. Agarwal. Mr. Agarwal, how can intervention through automation help an organization to create advantage in manufacturing?
Thank you, Anupji, and good noon to all. Before I begin my discourse, sending our support from this forum to all the COVID warriors out there who are trying to keep us and the country safe. Anupji, you have just spoken about supply chain. In fact, two things abound. Manufacturing is all about handling material. And as we handle the material, information about the material remains to be a critical aspect in manufacturing. And it does touch upon the incoming material, the in-process material, and outbound material, though the shape, size, assemblies would keep on changing depending on the manufacturing. So allow me it's all interconnected and it's material. So allow me to switch from calling it a supply chain to material chain, because supply chain is generally about beyond the boundaries of a factory, how incoming and outgoing generally are going. But in an interconnected world, in portability of information, as we are talking about, physical boundaries are therefore mitigated. So everything is about remote information, information as such, portability of it, but linked to movement of material. And if movement of material is so critical to manufacturing, it has direct consequence on the enterprise. I would like to invoke maybe a picture along that. Could we have the first part? Thank you. I would say, given our material chain, given the information, it is the efficiency of how we deal the material with. Any kind of intervention through automation and information transparency increases the efficiency of the operation. And that's a very, very desirable aspect in the material chain. And the more information we have, what is happening, incoming, outgoing, and on the shop floor, a good transparent information will help us to reduce waste. And it becomes more and more critical. In fact, mitigation of waste is actually a direct saving. I'm going to talk more about it down the line. And as the information along the whole chain of the enterprise, we started that in beginning from my colleagues, how information of the enterprise, information about the connection of the machines, the health of the machines, the operations of the machines. And if we couple it with the information of the material in the enterprise, that paves the way of a lot of success and efficiency. And in hard times, as we are at the moment, all of this culminates efficiency or waste management or information transparency and exchange. All of it culminates into the most coveted aspect of the enterprise and the individual, that is the cost. So I've tried to indicate how through the material chain automation, one can engage into increased efficiency, reduction of waste, increase of information, and reduction of the cost. So to answer your question, Anupji, these are all directly related. Without going into the nuts and bolts of which technology, because one size doesn't fit all. But depending on the size and type of operation, intervention, as you said, through automation remains to be the key. Picking up the threads from the last talk, people are very wary about handling of material because there is a surface contact. So human being and surface contact, surface which will go through successive stages within the manufacturing organization, thereby increasing the proliferation of infection. How to minimize it through automation? In fact, AGV, I'll invoke again, a guided vehicle which is quasi-navigating, fully guided, fully navigating, depending on the size, type, payloads, is turning out to be the key. In fact, talk about material movement within the hospital, one of the most successful aspects, as you all know, is also how AGVs are being deployed to deliver material, medicines, papers to the beds, to the wards, so on and so forth. But having had that, RFID is also an intervention, roller conveyors, robotics about pick and place. Of course, when we talk of robotics, the ticket size is a prohibitive factor along with the engineering that goes into a cell. But again, not to forego robotics only as a big ticket, I think it is a show saver in quite a critical aspects post-COVID. And I think with reduced payload capacities, quick installation times, we do have quite a few appreciable solutions around robotics at this moment. Of course, the safest and the simplest bet remains barcodes, along which people do identify the material through the different stages. And all of this, if implemented in the most, I would say, ergonomic and viable way into an operation, thereby increases the distances between the operators and decreases the surface handling of the manufactured aspect or the packaged material, so on and so forth. I can go on and on, but there are quite a few solutions currently on the bouquet of automation which actually help in outbound and in-plant material handling. Quite a few labeling, vision, and so on and so forth. But what am I actually saying? If I can filter it or distill it down to certain turnarounds, most of the times in the enterprises, we are struggling on reprioritization, identification, what came from where is something lying around. So I would say preferential vendor items, reducing human error, because once the aspect or the material is typified through many solutions that might be, these are distance reading, optical reading, whatever it might be, they are reducing human intervention and therefore the human error as such. The vendor management, the timing, the incorrect billing. See, increased amount of data and goods waiting to be processed is also getting inculcated due to human error, incorrect allocation. So with partial and semi-automation and not big ticket automation, these very key areas can be added, especially in volatility times like this, where probability of error actually rises multifold. Talk about that in the inbound, the system efficiency, and so much we have talked about remote visualization. That means if right from the vendor end and the supplier end, if the visualization starts happening, then your GRNs, your inbound material prioritization can be done without excessive physical human intervention. And this becomes all the more necessary in the recent post-COVID scenario, thereby also laying foundations of an increased efficiency in the operation. One of the biggest banes in our manufacturing is material rejection and warranty handling from the supply end and also from the outbound end. But if the material so is identified, stacked, palletized, typified, soft tagged, physically locatable, monitorable, it increases again the transparency and the efficiency. Believe me, when we talk about Industry 4 or smart, one of the aspects to look at manufacturing can also be information-driven manufacturing. And automation, creating hence the information or the transparency for handling of material, is a big pillar of strength into the manufacturing. In fact, one of the bigger banes in multi-part systems is marrying piece part to the invoice. So very simple solutions, in fact, with proper and a simpler setup, maybe cloud-bound, server-bound, as my colleagues have said, Ethernet backbone in even small plants due to availability of minimum IT infrastructure has started to be existing. So simple databases which are dealing with invoice and piece part marriage helps a lot in transparency. In fact, a couple of manufacturers I've been talking to, the raw material inbound is stopped at the moment. Most of the people are saying, Ravi, if we knew what is the raw material lying at our shop floor that is quick convertible to the generic parts and generic goods we manufacture. So even if 33% workforce is there and we start jogging the machines, a quick assessment of the workforce and quick assessment of the raw material at hand can actually help us convert the dead material, the dead raw material, into quick available goods and henceforth the cash, therefore kick-starting the material chain. But what is stopping is transparency and availability of data, which actually is quite probable through minimal automation. Could I have the next visual, please? Thank you. So as the material has come into the factory, one of the bigger banes is, what is my inventory? Can I have first in, first out? Because most of the people talk about it in actual manufacturing. You and me know how first in, first out is so very difficult to implement in a manual fashion. Therefore, if we have this continued reduction of human interface and redeployment of human labor, because in reduced attendance scenarios, as we are going to see, how do you redeploy your labor force in the most efficient manner, given that mundane tasks of just movement of material is automated appropriately? The ticket size of, let's say, an AGV can be below par of ₹1,00,000 to, depending on payload and sophistication. But I've come across so many people who are actually developing these in-house and deploying that for simple redundant material movement and redeploying the labor force in more productive and value addition areas. It goes on because it's uniform. One of the key aspects in this material chain remains, if the material so produced is identified and it's in a connected enterprise, remote visualization included, is the genealogy. So if the piece part being produced can be characterized, its information can be stored, that goes a long way. Goes a long way within the plant, reskilling, improvement of the defects or removal of the defects, and also goods assurance to the outbound. Similarly, in process, work in process management and prioritization. Goes without saying, characterization of material chain goes a long way into the safety as well, because it's not only the physical safety, but proper categorization, storage, temporary or permanent of the material and its actual location in the plant is so very appreciated. Moving immediately to the outbound, please, the next visual. The system leakage. The bane in manufacturing has been, well, what is the wastage and the system leakage, whatever that might be the reasons, moral, immoral, or whatever. But information-driven manufacturing or information-driven material change actually helps us arrest system leakage. And a system leakage goes directly to add into reduction of the cost. And these are many proven cases, tower house, lighthouse projects, proven cases where all this has been done. Warranty handling or inventory management. Another part in outbound supply chain or material chain remains to be the dealer stock visibility in an enterprise. So one of the key thing is a lot of time and resources are always spent in haggling as to what is needed, what is the stock, what is the work in progress. So visualization of information with quasi part or full automation therefore helps us in a very quick recovery in the post-COVID scenario. May not be big ticket, the prescription remains within our own processes, whichever are the pain areas, we start with it and then integrate horizontally and vertically. I would say that remains to be one of the key areas I would prescribe in terms of material identification and chains of the material for a successful enterprise post-COVID. Over to you, Anupji.
Thank you, Mr. Agarwal. I think you've clearly laid out the roadmap for foolproofing in areas of identification, tracking, tracing, etc. I think there is a need to now look at another aspect of business, which is, traditionally manufacturers and manufacturing oriented companies have always been comfortable with a steady flow mentality, which means once a line is on, it'll keep on producing the same stuff and, try and get economies of scale. Now, many believe that in the new normal, the business will be challenged on this mentality. There would be frequent adjustment in the production plans. The machine setups may need to be changed, and at the same time, without having any drop in quality. So I would like to now call upon Mr. Paranjape. Mr. Paranjape, in the light of all this challenge happening, how should manufacturers cope with this? And is there any role for automation?
Yeah,
Over to
thanks,
you.
Anup, and very good morning to all the participants. Before I go on to the topic, I would like to touch upon the deployment of automation in India with two sad examples, recent ones, both of yesterday. The first one is Vizag, where we know, as per the report, 11 are dead. Apparently, as per what I have read, the cause was a malfunctioning of the valve, but it also says that the particular, that styron, is stable below 20 degrees centigrade. Now, if that be the case, then I wonder whether there was any control system that was in place to monitor and control the temperature of that particular tank where styron was getting stored, or whether that particular loop was bypassed in a hurry for a quick startup. I'm touching about this particular point because we are right now at a stage where everybody is in a hurry to start. The second example is again of yesterday, where there was an explosion in NLC Unit 2, where apparently there was a blast in a boiler, and as per the report, the reason is likely to be uncontrolled pressure and temperature. Again, it brings me to the point of the control system. Now, why I'm highlighting this is everybody is in a hurry, as I said, to start. And in that hurry to start, there could be a tendency to bypass controls which may be irritants. But I would urge all that please treat automation as something which is a necessary element of the system and not unnecessary but a devil. I am deliberately using this very strong adjective, devil, because many a times automation gets deployed just because there is no other way out. Therefore, when you are starting, please not only check the automation system, but also check the mechanical elements. This is what I wanted to submit to all of you in the light of these two very sad incidents where people have lost their lives. Now, Anup, you touched upon the topic of the new normal in manufacturing. This is again very, very surprising that we are calling this as a new normal. We all know that automotive has always been at the front end as far as automation, deployment of automation is concerned. And Automotive was the first industry that I came across where they started the tailor-made mass manufacturing. I'll just give an example. You have a car which will be red in color, which will have a steering wheel with a leather cover, which will have an upholstery which is either checks or leather, which will have X, Y, Z features. The model is the same, but the variants are 100, and all these 100 variants may be moving on the assembly line. This is a reality. And this reality has been faced by automotive for a number of years, and the automation systems have been in place to meet this reality. The other areas of manufacturing will have to catch up with what has been available and deploy the available systems. Now, Anup, I would like to have the first slide. Yeah, the reason to show this particular slide is in our dialogue on the first, I had mentioned about integrated approach. It is this integrated approach which is going to be required when it comes to meeting customized mass manufacturing. For the simple reason, I know of an organization which has deployed IoT, but okay, even if you leave the cloud part out, why I'm saying IoT is because customers are placing their orders on a mall. From the mall, the orders are going into SAP as a sales order. From the SAP is doing the MRP run. This is connected to the product lifecycle management system deployed there, which is then triggering the whole manufacturing process. And I have seen with my own eyes a product which is normally manufactured in millions per year, a batch size of 10 with 3 variants moving on the line. So it's not something theoretical. This has been achieved. But if this is going to be the requirement from the market, then we need to have an integrated approach to our manufacturing automation. Next slide, if I can have. This tells more in, what should I say, boxes. What we need to have. We need to have the field level, the control level, the operational level, the management level, with both management of the business and management of the product processes and resources. It is only when you have this kind of an integrated approach that you will be in a position to meet this requirement if this has been identified as the pressure point from the market, if this is being considered as the new normal for the manufacturing industry. Similar examples also exist in pharma, where again the batch sizes are becoming smaller. But the more concrete example which comes to my mind is automotive, because it has been there for a long time. The other point is, how do we be in a position to do quick startups? If I have heard it correctly, it was in the first presentation that we may have, I hope not, similar instances even in the future. If that be the case, then we need to have the possibility of simulation and a digital twin. Now, you can have a digital twin through software packages, and you can also have, with the help of the same package, virtual commissioning possibilities. If you are in a position to do virtual commissioning where you are simulating your controllers and even field devices, then in that case, you know that your actual commissioning is going to be trouble-free. To add to that, if you have the web servers, then secure web servers, then you also have the remote operation possibility. In fact, I know that the packages which are available in the market today, the simulation packages are exactly like the flight simulators, where you can create conditions and find out what will be the response. This is something which was not available in the past, and this is also going to be helpful because what if kind of scenarios, and these what if kind of scenarios are the ones which we will be facing, because as I mentioned, we are in a very volatile, uncertain, complex and ambiguous world, VUCA, and therefore we have to be prepared to face such situations. What is lying in store for us? What is already being thought of? Can I have the last slide? Well, this is what is the industry is working towards, where you see the autonomy components, you see the self-configuration as far as commissioning is concerned, self-optimization, and the holistic modeling. All that for consumer satisfaction. Now, this is not the forum to go into the details, but this is what is going to be available if consumers are the ones which are driving us to go to this new normal of, let me say, a single piece flow, then this is what is going to be the requirement for the near future. With that, I conclude my presentation. And in any case, during question answer session, if there are any questions on this, I will be very happy to answer them. Over to you, Anup.
Thank you, Mr. Paranjape, for the wonderful insights and also the cautionary advice you have given. We are therefore actually observing a rapid convergence of controls, communication, and collaborative technologies that augurs well for smart manufacturing. May I now request you, Professor Jha, to share your insights on what is really unfolding on the ground in India also in the area of smart manufacturing, and also share how is that going to be relevant for our small and medium enterprises. Over to you, Dr. Jha.
Yeah, thank you, Anupji. And it's really a good insight given by the other panelists on the subject. I will be just going to share my thought process on understanding the smart manufacturing, and I will focus a little bit more on the small building blocks which will allow us to experiment on. The good thing is that we keep on hearing these smart manufacturing technologies from along, and then this is the hour where we should do experiment with whatever the limited resources we have. So I just quickly touch upon what exactly we are talking about when we are talking about smart manufacturing, how it is going to be different from what we are doing traditionally. So I'm just throwing some light on the key aspects of the smart manufacturing. Last time also I was just emphasizing on the connectivity part, and everybody on the floor who are listening or who are on the panelists, they are agreeing to that. Certainly this is something is the foremost step to enable this smart manufacturing concepts. So when we are talking about the smart manufacturing, connectivity is the first thing required. And when we are talking about the connectivity, certainly there are big pictures to connect all the assets every time they are getting all the data from these devices. I'm just talking about the minimal thing that you can start with. So when we talk about the connectivity, whatever best sensors or the most critical data that we can bring into the system, how this real-time data, whatever will be coming to you, will be helping in building in a collaboration with your suppliers and customers. So if you see that these technologies, though being laid down earlier, they are quite relevant in the time of need, which we all understand today. This will also help us in establishing a good collaboration between the different departments in the organization as well. Then we will be talking about the optimization of the resources, because at this moment we are running short of many resources, whether it's in the money, the manpower, the material, lot of things. So we should be very cautious about spending those things. When we talk about the optimized operations, optimized functionalities, we will be looking forward for the reliable and the predictable production capacity that we have. How we can increase the asset uptime, that is very important, because now we have constraints and we would like to utilize the resources properly. We will also be talking about automated material handling. I think that we all familiar with how the AGVs and the cobots helped a lot our healthcare people to do those tasks in these difficult moments. I'm not just saying that you should also go for that, but we need to think through some of the mechanisms. May not be the full-fledged cobot or the AGV, but even the low-cost options can be tried out to do material handling with minimal human intervention, because that is the need to run the factory in the current situations. And certainly the minimized cost of quality and the production. I will just touch upon the other three key important aspects of the smart manufacturing, because this is something we are trying to build upon. When we talk about the transparency, this is another layer which is very important to build the confidence with the customer. Even it will be helping you in demand and in estimating the right forecast for the demand, so that you can just run the facility for that desired need only. And moreover, the live data that will be available from the previous options to get the connectivity established, you will be able to do a better decision making. Most important aspect is that to avoid the wastages, we should always be proactive. We have to follow the proactive approach, which is very much embedded into the smart manufacturing concept. So when we talk about predicting the anomaly, we need to identify before the situations go out of hand. Same time, in terms of the stocks also. So I'm not just saying that you will be going to implement everything right now, but what I just want to emphasize on, these are the key aspects of the smart manufacturing, and you can start from anywhere in the minimal capacity you can. Not only these things will give you advantage today, they will be giving you an advantage in a long run as well. So even if you can identify the supply quality issues earlier, certainly, as we were discussing, the real-time safety monitoring is very important aspect, because when we have a limited people around, how the systems being operated, these are the critical things to understand. Now, the last one is certainly can be thought through in the long run, but it is very important the way you have seen that the factories has been transformed to produce a good which is in the most important or the highest requirement. So agility is something which plays a bigger role, though we have not thought through this concept when we set up the facilities, but certainly now we can start thinking towards those implementations where we can have this flexible and adaptive scheduling possible. We can modify the layouts and equipments in such a way that we can ready to produce something else also. So rather than keeping the factory closed for next 3 months or something, whatever is being coming up to us, we can start producing which can give us a benefit. That's the reason that most of the automotive manufacturers are now even thinking of making ventilators to some extent. That will be helping twofold, running the facility, helping the organization, at the same time it will be helping the people also. So these are the key smart manufacturing aspects which I would like to emphasize on. Now in the coming slides, I will be just sharing some of the quick steps and the implementation that can be easily feasible without much investment. So this is the one which I would like to share again, though it has been shown by Mr. Paranjape also. When we are talking about the connectivity, this is how we should build up the layers. So today I'm not emphasizing that we should build the whole 3-layer structure right now, but certainly we can start with the connectivity at the field level. So I have a quick example to discuss with you. So I just put the case where you have how we can establish a data exchange with the machines and IoT. So I have just taken the two examples. One is the automated machine that you may have. So maybe your CNC machines could be a part of that. And other aspect is the legacy machines that you have. So to start with, whenever we are thinking of building in a field level connectivity, and when we want to at least get the minimal information which will give me an insight about the operations, one where we already have PLCs, sensors in place, the actuators and the network is in place. Only thing we need to work towards building the connectivity. So we need to look forward for the hardwares like the IoT gateways, or maybe some kind of a data aggregator running on some server. So those kind of things can be expanded. So you may not be end up in doing much investment. Only thing you have to establish a minimal connectivity with the system. On the other side, if you have a legacy machines, so what I just want to emphasize here, we need not to convert this legacy machine into an automated machine, but certainly we will be interested in certain minimal information from these legacy machines as well to understand the operations. So for example, this is one machine where I can say that I should capture the speed, feed and depth of the machine if it is possible. And then we need to identify the right sensor which will enable me to do that. The same thing, we would be capturing some of the vibration signals to just take care of the hazard part as well as take care of the machine health part. Energy monitoring is another aspect can be possible through this. We can also have a very minimal number of IOs which will be helping us in getting the right information. So you can have some hardware which will be giving you direct input about the coolants, whether it is running or not. So at least you will be able to prevent the damages into the machine, and then you can take any preventive actions also. Even you can monitor the power on and off of the machine so that you will be able to know that for how much time the machine keep running, not running, and to what extent it is being utilized. The idea is that in those situations where the machines will be like this, we will be certainly look forward for some minimal hardware which will give us the flexibility to interface these sensors. At the same time, it should also give me a provision to connect with the network. So even a low-cost PLC could be one option where you can have IOs available, and other side it can give you an Ethernet connectivity which you can plug in into the IoT gateway to pull that data. So this is the way we can at least start with establishing a data exchange with the machines. The next thing that I would like to mention that certainly we should be aware of. So those who are in the field of automation, they will understand that, though the way I have explained the task in the previous slide is not just so simple. So idea is to understand the different protocols in the machines, the system that's already being deployed in your facility, and how you can build the bridge between the different hardware to get the data from them, and how that data can be made flowing to the IoT gateway. So after that, so there are two aspects. Once we have the data, one option is that you can directly build some of the services and solutions onto the data that you are getting. Most of the time people just build up a small quick dashboard to get an information visually available to them. But in the long run, you can always think for a platform where you will be at least modeling the behavior of the whole system. So whenever we talk about the industrial IoT, we always look forward. It's not just data that you will be getting and then trying to visualize immediately. We can think of modeling the whole stuff. So you can even model a machine, you can model the whole production line, you can model the whole plant, so that we can able to correlate the events, the data that are flowing through the system. So as a IoT platform, we should always try to model even the people, and applications can also be modeled into the platform. So that's the bigger picture of the IoT that should be built up on the basic things. The most important thing that we require today is the gateway. So when we talk about the connectivity, this is something which is required to build up, and it's not just for one machine. So if you have a bunch of machines, this gateway can help you in connecting most of them. So idea is that to extract the data from different controllers or different PLCs which are having a different protocol of communication, and finally make that available to the system further in IoT platform. Or you can establish a cloud connectivity through the MQTT. So this could be either a physical hardware platform, or this could be a kind of a data aggregator can also be used to do this. So even if you have a minimal implementation, you can plan for that. Just deploy a small data aggregator into one of the system in the plant or the facility, and you can pull out the data and make the connectivity possible. The next thing I will be just discussing the workflow that is to be implemented for the data. Once you have the data, once you capture it, how to organize and visualize and then analyze, because certainly it's not just getting the data that is enough. So what I have just explained from a very basic level of establishing a connectivity, how you can leverage the benefits out of that basic connectivity. So as you see, the first block says once you establish the data aggregator or the IoT gateway, at least you establish the connectivity through to your systems to fetch the data. And then we will bring out this data to an IoT platform to store. And at the same time, you can even build up the visualization on top of that. Later, I was just suggesting that you can model the data or the systems into the IoT platform. That will give you a bigger insight later on. Now, based on this data that you have stored and captured, you can build more visualizations, more dashboards, small apps through that the people can have that information readily available to them. And most important part, then set up the notification services, because at any time when there is a variation on the parameters, we would like that notification to be generated from the system directly. So we can configure the same IoT platform where we are getting the data to generate those notifications. So this is very important aspect. So wherever there is a variation, you may not be able to get a chance to look into the enough data. You just want to get notification when there is any variations. And later on, you can think of, once this structure is being established, you can later on use some of the readily available analytical engine into this platform. Now, I will just quickly, in the next 2-3 minutes, I will give you an examples how the technology can be deployed. This is one of the example where in a small use cases of computer vision, augmented reality, and cloud connectivity can be built. What I'm just throwing some of the things that these technologies, because these days we have we have a limited manpower movement today. So those who are in the domain of automation, they can expand their learning and knowledge to deploy these kind of use cases in their facility. Here, if you see the example, what we have done is capturing an image of a PLC and then processing that data at the remote cloud to do the image analysis. Because many times, you may not have experts available all the time. So what we want, that if there is a fault into the machine, if there is a fault into the system, whom you are going to consult. So in that case, what I can do, that I can just capture the image of that system and then upload to the server, where I will be using some kind of an image analysis software. Here I am just giving an example of an open computer vision, OpenCV, where that system will analyze the image that you are being uploaded, and then from that it can detect what type of fault it is, and through AR into the same application from where you have captured the image will give you the further guidance. So the real-time information, it's not just an image, it's basically the real-time information captured being analyzed into the cloud, and then the information sent back to the person in the AR. So that's a kind of a simple closed loop communication can be built where you have utilized that. The another case that I'm just going to highlight over here, where you can use an edge hardware, because most of the time in the industrial facility we have a PLCs in operation, and when we are talking about the vision part, they don't have a capability to process that kind of a data. So this is one simple application where you can think of a small edge hardware which is having a GPU inbuilt into that, which is capable of doing image processing, and the data can be communicated back to the PLC. So this kind of an implementation can be thought through for certain quality parameters monitoring and through vision and through sensors. And finally, the data and the decision making can happen in the cloud and then communicated back to the PLC also. You can also use an augmented view to give an information to the user also. I think these are some of the technology pieces I have just discussed. We are enabling people to understand and learn these new technologies and experiment with them. This is the real right time to at least deploy some of these options. Thank you very much. Anup, over to you.
Thank you, Dr. Jha. I think you really brought the interest alive in the audience, and I'm sure that most of us who are now waiting for our turn to go back to plants can do a lot of self-learning. Now, let's park technology aside for a moment and let's come to the economics side of business. Almost every industry I speak to has taken a big hit on their overhead. And also many of these are being challenged by demand drop. Mr. Nandakumar, what will be the basis of future competitiveness? Do you feel companies, big companies or small companies, will cut investment on technology?
Thank you, Anup, and all the participants. Welcome. Anup, in one question you brought up some very wide subjects. The overheads, demands drop, competitiveness, and technology and investments. I would like to take our delegates to slightly to generic economic situation. See, for a country like India with 1.3 billion population, and when we look at our GDP, presently the GDP is 60% is the service and 14% is the agriculture. The industry industry including the construction contributes around 26% only. Even in that 26% the industry, construction is around 10% and manufacturing is around 16% as on date. For a country like India, which is developing, a 16% contribution by manufacturing into GDP is not sustainable for a country like India, especially for a developing country. It's not only for India, any developing country, if you look at, they will have manufacturing contribution in the GDP at least to the extent of 28 to 35% minimum. So for a country like India with 16%, it is not a sustainable contribution. So we have to really look at the basics. So how to enhance this manufacturing contribution to GDP from 16%, if not to 25% on a period of at least 5%, at least by 2025 we should be achieving around 21%. So in my opinion, the demand drop, there could be a demand drop shortly for a while, but it's not really a demand drop. It will certainly be picking up faster because we ourselves will not be able to sustain that type of manufacturing output with the 16 or 18. So we have to certainly get up to minimum 21% over a period of 2 to 3 years. In which case, we need to enhance in the first phase manufacturing efficiency, manufacturing output. Any greenfield investment will certainly take time. So we have to look at the brownfield where we can get manufacturing output higher, efficiency is higher, which means we have to have a reduction in waste, increase in efficiency. That's where our automation comes into picture and the digitization comes into picture. Then enhance the skills. So the 3 M's which our friend Sivaram has told, men, materials and money, will certainly play a big role in that. So when it comes to these requirements, certainly the 3 areas which will really focus, which really everyone will put attention is technology, which again goes back to research and development. Then on the innovation, continuous innovation to enhance competitiveness. Now, if you really look at what are the areas where opportunities exist for technology, I would park automation on the sideline for some time. But given the situation, the pandemic, COVID-19 situation, I am sure henceforth there will be quite a lot of focus on medicine and medical technology. Because no country, no civilization can face this type of pandemic over a period of another 100 years. So certainly people will look at what are the new areas of medicines and medical devices technology, which could be drug discovery, vaccines, medical devices, or applications of that, and or medical devices in relation to that, nanotechnology, new materials coming, and also along with that will come advanced materials will come, special purpose alloys can come, or composites can high-end polymers can come. So there are a lot of investments going to be there in technology areas in terms of new investments. And at the same time, in the current manufacturing scenario, there will be a focus on advanced manufacturing technologies employed. One could be the additive manufacturing, which is certainly picking up, especially on complex solutions, complex components providing at the short notice, additive manufacturing. Precision manufacturing, again, comes into play for the high end of the electronics as well as automation. Then comes nanotechnology, robotics, in order to get efficiency, higher efficiency and less waste. So there are quite a lot of potential coming into the new technology areas like robotics. I'm 100% sure most of the companies will employ now robotics in the first instance itself for them to get competitive as well as better throughput. Then comes augmented reality, using technology areas or virtual recognition. All these areas, I am absolutely sure no company will reduce their investments in technology area. But on the other hand, they will look at investments increase in technology area to enhance competitiveness, to enhance, I would say, better product lines, better product mix coming into the market at a short notice. So the coming days, it is the companies which are focusing on technologies who can sustain in the short term as well as in the long term. Over to you, Anup.
Thank you, Mr. Nandakumar. I think, yes, it looks very promising. But let's get a final vote from our audience. What is it that they think? Gentlemen, we are now almost at the end of our program. So we have a poll for you, and then we'll open up to question and answers. We have received some questions. Some of them have already been addressed by speakers. So if there are any more, please do that. But before that is the poll. So the poll question is, what is going to be the India advantage in manufacturing in the new normal? The choices are A, creation of jobs and decentralization of manufacturing in India. B, smart manufacturing enabling more global presence of made in India goods. So these are the only two choices. Your vote has already started. Let's do this fast because we are a little beyond the stipulated time, and my apologies for that. But we'll try and get straight to the Q&A round. Okay, I think we have a clear trend emerging, and maybe we can flash the results to the audience. There you see. The trend is very clearly in favor of alternative B, which is smart manufacturing enabling more global presence. I know Mr. Jha would have influenced that decision to some degree, but that's on a lighter side. I think the trend is pretty clear. We all know the direction in which we need to head. The only question is, at what pace are we going to move in that direction? Friends, now we will come to the question and answer session. So let's look at that one by one. I'm going to take first those questions which are addressed to specific panelists. Mr. Chandramouli has a question for Mr. Ravi Agarwal. What is material surface contact?
Thank you for that question. It remains that the work in progress actually is touched by many handlers and operators within a plant. And if we look at the new normal, a common surface which is touched by many people in the process of manufacturing is not such a welcome idea anymore. So the whole idea of talking about it was, how can we avoid multiple touch by different personnel of the same work in process? So it's ideally talking about how can we minimize the surface contact by multiple people. And the whole idea was there are some appropriate automation solutions which can help to mitigate this. Over to you, Anupji.
Okay, thanks, Mr. Agarwal. There's a question by Sudhir Bachlu. I think that's already being addressed. And there's another question by Mr. Sunil David, which is about, and maybe between you, Mr. Agarwal, and Mr. Paranjape or Dr. Jha, one of you can answer that. Do you think a digital twin of the material chain will enable manufacturers to leverage information power? So we've been speaking about digital twin of the machines. Here, the question is related to digital twin of the material chain.
I would invite Mr. Paranjape to kindly throw more light on it.
So I'm here. Somehow when it comes to approach, a fragmented approach is not something that I would vote for. But all the same, if you are creating a digital twin and you want to use it for optimization, I don't know from where you are going to get the necessary input to your system. Let me give you an example. Supposing you are having an ERP which is then doing the MRP runs, and then the MRP runs are placing the orders on your vendors, and in the reverse direction the vendors are going to supply to you purely on the basis of only the supply part. The creating a digital twin, I don't know what you will be optimizing. So this is where I'm lost.
Okay, we'll get Mr. Sunil David to respond to that offline, and we can pass on that question back to you, Mr. Paranjape. Most of the other questions we have are of a little general nature, addressing more, who are the people who could help the small and medium enterprise prepare a roadmap for investment in a structured way. There is no, ready answer. We will, as AIA and as a Foundation for Smart Manufacturing, offer a platform where we could take more specific use cases so that most companies can actually see something in it for themselves. There's also a request to the audience, and for those who are from the manufacturing area, you must be able to identify at least one major pain point and present that to us, because there needs to be a starting hook for an engagement, and also to know where really the pain lies. You will have more opportunity coming across to our experts. We will now be moving on to a slight shift in our series. We'll be moving more to specific solutions. So your questions will really help us address that. And
Anup, could I add to the last previous question, please? Just a little comment to the previous question.
Yes.
See, from what I know,
Yes, please go ahead. Mr. Shivram, you're there? Okay, maybe we've lost him. While he comes back, let me just complete what I was alluding to. We will also be moving into a little bit of training through these online sessions. So you will get a chance to really come and interact more. So while we wait for reboot, there's a lot to catch up on technology and understanding each other's dilemmas and possible learnings from each other. So the show is on. Only we are now going to move more from an overall perspective to more specific solutions. I don't see Mr. Shivaram yet back. So maybe with this, we will end today's discussion. We've gone ahead by 10 minutes. My apologies once again. And I hope to see you back. Can we now block our calendars for the 15th of May? You will get an email about the timing and you will get more information on the speakers for that session. Thank you, participants. It's been a pleasure to host you, and thank you to my panelists, Mr. Dilip Sawhney, Mr. Shivaram, Mr. Ravi Agarwal, Mr. Vijay Paranjape, Professor Sunil Jha, and Mr. Nandakumar. Thank you all, everybody. Goodbye. Stay safe, stay healthy.
Thank you so much. Thanks.
Thank you.
Thank you, everybody. Good day.